What is going on, my friends? Welcome back to the show. And then let's carry on from where we left off in our previous discussion. In this discussion, we're gonna briefly run through the memo version of the Knapsack. So basically, the main difference between just the regular recursive version that we spoke about in the previous video and this one over here is that this one has a memo, and the importance of these memo is to basically cache all of the computed subproblems that we encountered when solving some of the other problems in the other evolutionary trees. By caching these results, we essentially saving ourselves some precious time, which we will eventually realize when we measure how much computational time we're spending on each of these slight variations of these solutions. So as you can see here, we have a function which takes two arguments that are needed. The first argument is an array with key value, and it's not really key value, but it's a value with two properties. It's got value and the weight properties, and that's what we are passing to this object here. And like I said before, sometimes some other people separate these values, and you find that you, instead of passing one array here, you're passing two arrays. This will be array of values, and this will probably be array of weights. But for me, I like to keep these things in the same thing, in the same object, because I see them as one object really. It's just an object with two properties in it. So I like to keep it that way. It keeps my logic simple and straightforward. And then the capacity here, right here, it's clearly the capacity in which the person or whatever abstract object we are dealing with can carry. And then the last thing here I'm going to talk about in a minute is the memo. And basically, this code is identical to this one here. The only difference is the memo. This one has an optional memo which we actually pass to it when we calling it recursively. And this memo gets filled for every newly computed value, such that when we come back to it at the later stage, we don't need to recompute it. I'm not going to go into too much details into how that happens. If you haven't watched my previous video, I'm going to link it in the description below. Be sure to check it out, and perhaps you might even want to check it out before you get to this one here, because that is very basic and important. So make sure you check out that one before, and then once you've understood what's happening, come through to this one here, and then everything will be crisp clear. So these here, what we're doing, we're basically initializing a two-dimensional array here. As you can see, if it hasn't been initialized, we initialize it here, and then we use it whenever we are recursively calling this function again over here. And I've already explained what this algorithm does. It takes the maximum value of objects within a sack or within an environment. In this case, I call that environment a supermarket. So maybe this person is stealing from a supermarket or something like that. So he's seeing all these different objects, He sees sees a bag of potatoes, or sees a bag of whatever he sees over there, and then that's part of these items here. It has a weight and a value. And yeah, so if we have a value here, we simply return it, and we no longer need to recursively compute all this thing. That saves us significant time. Otherwise, we have to calculate it from scratch using this take item or leave item. And when you leave an item, you simply just call this function with excluding the first item in the list. Remember, these items are not sorted by any order, but we take them one at a time. And then you simply remove this, and the capacity remains the same, and you pass it the memo which you are using, and then you save yourself some time. Otherwise, if you want to take an item, or if the maximum of this item can be gotten from taking an item, then you simply compute it this way by taking the value of the item as well as the aftermath of taking that item. The aftermath is defined by you slice off. If you don't know what the slice function thus it basically chops off your array, and this function takes 2 arguments. So if you read this thing here, it explains to you what this function does. The second argument, as it says, the index to the end of the specified portion. And so that just means if you don't specify it, it takes all of the items in the remainder of the list. And then here you know once you've taken an item, you subtract its weight from your remaining capacity, because now you have to account for it as well as passing it the memo. So that's basically straightforward. And then once you have taken that maximum, you store it in the cache and then return it. And then let's quickly compare the speeds of these algorithm here. And to do that, I'm gonna take you through here. So on this here, we have our Knapsack capacity is 1000. In this case, this one we've already spoke about. We've already spoke about this one. Right now we're on this one, so I don't need breakpoints there. I'm gonna take them off. And then yeah, as you can see, it's this function here. It takes in these options object here. It's really an array of objects. And then see the capacity here is 1000. And all these functions, I'm giving them the same inputs just so I can confirm my outputs and computation, just that they are correct. With that out of the way, let me just quickly run you through and show you how much time this thing actually takes. As you can see, these two have already computed. This one took half a second. This one took significantly smaller. And let's just step over this one. You see this took this amount of time. So I'm just gonna continue all of this because I don't wanna affect the time of this one here. So I'm just gonna go ahead. As you can see, this one here now came third best. Our best one was this one here. This one was half a second. This one was 11 milliseconds. And then that's it. You can clearly see that this is significantly faster than this one here by simply adding this cache here. Let me get to you. By simply having this cache here and using it, you get significant improvement of time. Like, there's no question about that. Look at this difference, is like day and night. So that's it for this session. And then in the next session, we're gonna talk about how we can optimize this even further. And this is a bottom-up approach solution that we're gonna be talking about in the next video. And then that's pretty much it. The bottom-up solution, it's really more or less reversing the order in which this recursive solution computes its value, and also saves you the overhead of recursion itself. And that's basically the biggest advantage of having your iterations in the normal forward way going forward. And without too much further ado, that's it, my friends. I'll see you in the next one, and stay in touch and keep fresh, eh?